Hey everyone, my name is Ganz and I'm a PhD student at the Technion. In this talk I will present to you my work named CLIPAG, Perceptually Aligned Gradients in Vision Language Models that will be presented in WACV 2024. So, as the name of the paper suggests, our work combines CLIP with perceptually aligned gradients. So, I will start this talk by introducing these two. CLIP is one of the most important vision language models, which effectively propel the entire field of multimodal research. CLIP contains two encoders, a textual one and a visual one, aimed at aligning textual captions with images. It is trained on a huge corpus of image-text pairs using contrastive loss, leading to a shared representational space. CLIP has an exceptional image-text understanding, making it ideal for various text-to-image generative tasks. For example, CLIP Draw utilizes CLIP for text-to-drawing generation. Specifically, they use CLIP to update the parameters of Bezier curves to match a target text. CLIP Styler uses CLIP for text-guided image editing by applying a CLIP loss to a style network, and Gan plus CLIP for text-to-image generation, and they do so by enforcing the output of the GAN to be aligned with the text prompt using CLIP. Now let's turn to discuss perceptually aligned gradients, or in short, PAG. This is a qualitative trait that upholds if the model input gradients are semantically meaningful and are aligned with human perception. One common way to visualize it is by evaluating the outputs of strong targeted adversarial attacks and check whether the modifications are meaningful or not. As we can see in this figure, robust models lead to such changes and therefore they possess PAG, while their non-robust counterparts do not. PAG is used for multiple practical applications such as image generation, solving inverse problems, and image refinement. Although PAG was studied extensively in the unimodal vision-only case, it was never studied in the vision language one. In this work, we aim to extend the PAG study to the multimodal case, and we aim to do so by equipping CLIP with perceptually aligned gradients, and to explore the applicative benefits of doing so. Now we explore two approaches for achieving PAG in CLIP model, which are known to work in the unimodal case. The first one is randomized smoothing, which proposes to consider the expectations of the network output with respect to some noisy input as the smooth classifier output. We note that this approach can be done at inference time without requiring any sort of training. The second one is adversarial fine-tuning of CLIP. To do so, we propose to extend unimodal adversarial training to the vision language case. More specifically, we propose to adversarially train the image encoder of CLIP while keeping the text encoder frozen. This can be done in a two-steps min-max process. First, we craft adversarial noise that maximizes the cosine similarity between the image and the corresponding caption. And next, we train the image encoder to minimize the cosine similarity of the adversarial inputs with respect to their captions. Next, we qualitatively evaluate the perceptually aligned gradients of three CLIP variants: regular off-the-shelf CLIP, randomized smooth CLIP, and a robust one. We calculate the input gradients of the image to maximize the cosine similarity with respect to a certain prompt. For example, on the top left, we can see a picture of a dog, and we try to calculate the input gradients with respect to the term dog. As we can see, the vanilla CLIP has no perceptually aligned gradients, and these input gradients are meaningless and blocky. The randomized version shows significantly more semantically meaningful gradients, and the robust counterpart show the most meaningful ones. Therefore, we consider the robust CLIP as possessing the best perceptually aligned gradients, and we term it CLIPAG, CLIP with perceptually aligned gradients. After that we've established that adversarially fine-tuning CLIP leads to perceptually aligned gradients also in the multimodal case, we move on to explore its applications. We propose to seamlessly replace the CLIP vision encoder with CLIPAG in a plug-and-play manner in several generative frameworks, starting from CLIP Draw, which is text-to-drawing framework. We consider CLIP Draw in two modes of operation, with and without augmentations. As we can see, the results without augmentations are almost meaningless, and this is attributed to the adversarial outputs that maximizes the alignment to the text target without performing meaningful semantic changes. Interestingly, replacing clip with CLIPAG leads to meaningful and improved results in both of the settings, and this is attributed to the better gradients of CLIPAG. To provide quantitative results as well, we evaluate the aesthetic score and caption consistency of 100 generated drawings of ClipDraw with and without CLIPAG, with and without augmentations. Notably, simply replacing clip with CLIPAG enhances the results significantly in both of the cases. Next, we study the text-to-image generation use case using the framework of wherein plus clip. We visualize the generated images with respect to different captions, and below we plot the improved results obtained by simply replacing the clip model with CLIPAG. This strongly demonstrates the effectiveness of CLIPAG in guiding the generation process of the wherein, and this is due to the improved gradients of CLIPAG compared to the vanilla clip model. Lastly, we experiment with ClipStyler in the text-based image editing use case. Similar to ClipDraw, we explore both the with and without augmentation pipeline. Using augmentation is crucial for obtaining the desired results due to the susceptibility of the vanilla clip model to adversarial attacks. As we can see here, simply replacing clip with CLIPAG leads to improved results. Moreover, we plot additional results for qualitative comparison. After demonstrating the effectiveness of CLIPAG in enhancing existing generative frameworks, we turn to explore it in the challenging generator-free text-to-image synthesis. We propose an iterative generation pipeline based on pixel space optimization. More specifically, given a random input image and a target prompt, we first augment the image with random augmentations to obtain multiple views of the same image. Next, we encode them and calculate the clip loss with respect to the target prompt, and then we update the image accordingly. We repeat this step several times until converging to the final result. Here we provide qualitative results of generated images based on various prompts. Notably, CLIPAG enables impressive synthesis results even without a generator. In addition, we provide FID and inception score comparison to other approaches which do utilize a generator. CLIPAG, which operates also in a zero-shot setting, leads to competitive inception and clip scores, attesting to the good image quality and alignment with the target prompt. Lastly, we experiment with controlling the style of the generated images by simply modifying the textual prefix. Here the blue box specifies the target style prefix and the prompts are presented in the top. As can be seen, the output appear to be oil paintings as intended. Altering the style prefix, for example to a graffiti, significantly changes the generated images to better match the target style. We can see similar results when changing the prefix to a childish cartoon. This is it. Thank you very much for listening and see you in WACV.